I mean the one with the FE.
We are live.
Above. Oh.
Hello, welcome to another webinar.
Let's talk it youth webinar.
Vish, you can begin.
Oh. Hello everyone, welcome back to another Let Us Talk It youth webinar. Today's topic is atoms, elements in the periodic table. Let's get started. What we'll be covering today, first of all, the intro. You can learn about each of the topics we're doing. Then we'll be covering the structure of the atom, how the atom works. Then we'll be telling you about the elements we've chosen to talk about today. And finally, the Q&A, or as it says here, periodic Q&A. Meet the panelists, or physicists.
Hello, everyone. Directly from the Delaware County of Pennsylvania, I will be talking about the mysterious and possibly explosive nuclear elements.
Hello, everyone. My name is Vish, and I'll be talking about zinc, an element that can be found in your body and outside it too.
Hello, everyone. I'm Veda and I live in Canada, and I will be talking about the elements platinum and titanium.
Now we'll be going to atoms and how do they work.
How to read the periodic table. The periodic table goes hydrogen, helium, lithium, beryllium. So you read it from left to right. And there's also an interactive periodic table on Google. Next slide. In the periodic table, it's actually kind of simple. The atomic number is the number it has on the periodic table. The symbol or the initials. The atomic weight will be on the right-hand top corner. The density, the boiling point, will be on the left-hand bottom corner. The melting point will be on the right-hand bottom corner. The name would be under the symbol or the initials.
Okay, I will be talking about isotopes and how they affect atomic properties. So let's begin with what are isotopes. Isotopes are forms of atoms that can have more or less neutrons than the regular form of the atom. For example, you can see in figure 1 the forms of hydrogen, protium, deuterium, and tritium. These are the isotopes of hydrogen. They all have different amount of neutrons than the naturally occurring helium element. So isotopes are atoms of different chemical elements that have the same number. Isobars are atoms of different chemical elements that have the same number of nucleons, protons, and neutrons. Isotones or atoms with the same amount of neutrons and a different amount of protons. Okay, so from here you reach the overlaps of particle physics and nuclear physics, where anything nuclear, anything that has to do with center of the atom, and particle, anything that has to do with the atoms and particles themselves. For example, neutrinos, not to be confused with neutrons, overlap. We know this stuff, or at least have a vague understanding of it, because of quantum chromatography example showed in figure 2, and the string theory and other theories that connect the bits and pieces of physics to help learn more about the physical world.
Which one using the atomic charge? Or was it Lemuel?
I'm pretty sure it was Lemuel.
Okay, well, thanks Vivan and Veda for telling us about how to read the periodic table, the elements in it, and isotopes. Now we can go on to our stuff. Why is this here? Here's just a quote. Atoms are everywhere, which is true. Everything around you is made of atoms. They make up everything and are everything. Let's just read a couple of these. Wait, they are? Comment by... And all these around here are just jokes. Anyway, here we go. And this is... Who's again?
Oh, mine. Okay. Hello again. I will be talking about hydrogen, thorium, and uranium, two very nuclear elements, possibly explosive. So hydrogen, named after water. Hydrogen is a component of water. Hydrogen is the lightest element. At standard conditions, hydrogen is a gas of diatomic molecules, which do not ionate. It is colorless, odorless, tasteless, non-toxic, and highly combustible. Hydrogen is the most abundant chemical substance in the universe. It makes up 75% of all normal matter, meaning 75% of you, 75% of the universe, 75% of the building that you're probably in is hydrogen. Well, hydrogen is a main component of water, like I said before. There are two hydrogen atoms inside of water, and the chemical makeup of water is hydrogen, hydrogen, and oxygen. Hydrogen is the most abundant chemical substance in the universe, like said, and that also makes it a very useful substance. So if we can get uses for it, it's not going to be hard to implement them, as getting them is not a problem. Thorium, named after the god Thor. So thorium is a weakly radioactive metallic chemical with the element Th and atomic number 90. It is moderately soft, malleable, and has a high melting point, meaning it's not that easy to melt. It is electropositive. It's an electropositive actinide. Actinide is a group of elements inside the periodic table. They're at the top, the bottom, the second bottom row, and then after that are the lanthanides. It is made of +4 oxidation state. And it is quite reactive and can ignite in air when finely divided. Similarly to other nuclear and reactive elements. Huh? Okay, next slide. That's not the right slide. Yeah, uranium. Oh, okay, uranium, named after the planet Uranus, derived from Uranus, the god. He's the god of the sky. Uranium is a chemical element with the symbol U and atomic number 92. It is silvery gray metal in the actinide, also like thorium, and it the periodic table. A uranium atom has 92 protons, 92 electrons, 6 of which are valence electrons. Right? Uranium is weakly radioactive because all isotopes of uranium are unstable, but everyday elements, for example iron, do not give off radiation because they're stable. Also uranium. The half-lives of naturally occurring isotopes range between 159,200 years, which is a geological instant, and 4.5 billion years, which is basically the span of the Earth. The most common isotopes in natural uranium are uranium-238, which has 146 neutrons, and it accounts for over 99% of all uranium on Earth. And uranium-235, which has 143 neutrons. So uranium has the highest atomic weight of all primordially occurring elements, meaning it has the highest atomic weight of all elements that naturally occur. Uranium occurs in the form of uranium ore. Next slide. Past, present, and future, hydrogen. In 1845, Sir William Groove, an English scientist and judge, created a gas battery. Here in the title, father of the fuel cell for this achievement. It generates electricity by storing hydrogen fuel, and that can be burnt. But he didn't create the futuristic hydrogen fuel cell that we know today that powers hybrid cars. He just made a simple hydrogen fuel cell, one that could barely provide enough electricity for a light bulb. Now, hydrogen is used for refining petroleum, treating metals, producing fertilizer, and processing foods. So by refining petroleum, it removes sulfur content so that the oil itself is more pure. Treating metals, that is for like making alloys or removing impurities from metals themselves. Producing fertilizers, they help in the production of fertilizers. And processing foods, they can be used for processing foods. The future. It can be transformed into electricity and methane to power homes and in the food industry. It can also be turned into fuels for cars, trucks, ships, and planes. Hydrogen can enable renewable energy sources to provide an even greater contribution to the green revolution. Next slide. Past, present, and future. Thorium. Thorium has vague origins and is only gaining uses recently as nuclear power becomes more feasible due to the fast R&D, research and development. Now, thorium is radioactive and its uses mainly lie in nuclear fuel applications. It is helpful in radiometric dating, meaning to use radiation to find the date of things. Many people use carbon dating to check the age of certain fossils. It is used in manufacturing of lenses for cameras and scientific instruments. It's also used in nuclear reactors. The future. Thorium can breed fissile uranium-233, meaning uranium-233 is a nuclear fuel for fission and not fusion. It to be used for various kinds of nuclear reactors. And they can be used in molten salt reactors. They're well suited to thorium fuel. And normal fuel fabrication is avoided. Past, present, and future. Uranium. Uranium had a slightly confusing past. It was used as a dye for certain ceramics. For example, in the image you see, it was used as an orange dye for the plates, but many people use it as a yellow dye. Uranium oxide was used as a coloring agent for ceramic glazes and in glass, according to chemical. So now, uranium is the icon of the nuclear age. It's the basis of nuclear power reactors and nuclear bombs. But even though there are no stable isotopes, it's used as a metal for non-metal things, for metal-like things. The future. Sufficient uranium resources exist to support the long-term sustainable use of nuclear energy for low-carbon electricity generation, meaning you can produce less carbon dioxide while creating lots of energy. For now, we haven't gotten stable nuclear energy that can produce a lot of energy without taking up more energy in the process, but we'll get there. So it also has other uses such as industrial heat applications for generating insane amounts of heat and producing hydrogen. Okay, so that was all. I hope you enjoyed.
That was very nice, Devon, and a lot of info on uranium, thorium, and hydrogen. Who knew uranium could have been used as a dye? Now I'll be doing my topic, zinc. What is zinc? Zinc is a nutrient found throughout your body. It helps your immune system and metabolism function. Zinc is also important to wound healing and your sense of taste and smell. With the varied diet, your body usually gets enough zinc. Food sources of zinc include chicken, red meats, and I'm not going to say the last. Fortified breakfast cereals. But wait, isn't zinc a metal? Zinc is a transition metal like mercury and cadmium. Transition metals are located in groups 3 to 14 in the periodic table, if you're wondering. And the transition metals are metals that can be changed in a way. Zinc is a metal as well as a nutrient. Having zinc in your blood cells isn't something to be concerned about, but it is perfectly safe for your body, but that doesn't mean that you can eat it. If you did eat it, though, that would be a very, very bad thing. Zinc is a very malleable metal, which means that it bends easily. Or bendable, yeah. Zinc is also used to make alloys, such as brass, nickel, silver, and aluminum. Zinc oxide is widely used in manufacturing of very many products such as paints, rubbers, cosmetics, pharmaceuticals, plastics, inks, soaps, batteries, textiles, and electrical equipment. So zinc is very useful in the world. And that's it for my topic. Now,
Can you refresh the slide real quick? I made like a couple of edits.
now we'll be moving on to Veda, talking about platinum and titanium.
Hi again. My name is Veda, and I'll be talking about platinum and titanium. Platinum is the 58th element of the periodic table. Its initials are PT. Platinum is used mostly for jewelry. Electronic companies use platinum for computer hard disks and thermocouples. Platinum is used in the chemical industry. Platinum is used in the chemical industry as a catalyst for production of nitric acid and silicon benzene. Titanium. Titanium is the 22nd element of the periodic table. Titanium is much like steel, but it is much more dense. It is an important alloying agent with many metals, including aluminum, molybdenum, and iron. Titanium is mostly used in aircraft, spacecraft, and missiles. They are also used for golf clubs, laptops, and bicycles. Titanium can withstand very intense temperatures, like very cold temperatures or very high temperatures. That is why they use it in aircraft and spacecraft. Next slide. The first written account of platinum was by Julius C. Scaliger in 1557. He described it as a strange metal found in between mines in Panama and Mexico. In 1783, French chemist Francois Charbonneau discovered and patented a method of producing workable platinum. In the 19th century, William H. Wollaston developed a commercial process for producing pure platinum. Titanium. Titanium's discovery was first announced in 1791 by the amateur geologist Reverend William Gregor from Cornwall, England. Gregor found a black magnetic sand that looked like gunpowder in a stream in the parish of Mannikin in Cornwall, England. We now call this sand ilmenite. It is a mixture consisting mainly of the oxides of iron and titanium. Gregor analyzed the sand, finding it was largely magnetite and the rather impure oxide of a new metal, which he described as a reddish-brown calx. Next slide. This slide is also about titanium. In 1795, Martin Klaproth discovered a new element and called it titanium, after the Titans of Earth goddess in Greek mythology. Many scientists tried to replicate the titanium alloy that Klaproth created, but it took over 119 years from its discovery until 99.9% of pure titanium was isolated in 1910 by metallurgist Matthew Hunter in Scanshetty, New York. Hunter heated titanium chloride with sodium to red heat in a pressure cylinder. Next slide. Comparison between platinum and titanium. Platinum is incredibly rare, while titanium is more abundant and you can find it in many different places. They're both very durable and incredibly resistant to many things. Platinum costs a lot more than titanium, morely because it is more rare and it has a higher composed, and it's found only in specific areas. Platinum does not cost as much as titanium because you can create platinum, and titanium you can't. They both require very little maintenance. Next slide. Facts. Platinum has a melting point of 1768.2 Celsius, while titanium's melting point is 1670 degrees Celsius. But they're both non-toxic. Platinum is prepared as a byproduct of copper and nickel. Titanium is the ninth most abundant element on Earth. Titanium is usually in igneous rocks and the sediment derived from them. Commercially produced platinum comes from South Africa. Thank you, and I hope you enjoyed it.
I wish you're muted.
That was a very nice presentation on titanium and platinum. It's really surprising how alike they are when they don't really, well, you don't really find them in the same places or such. Who's doing lithium and beryllium?
No one.
That's just part.
And then we have transition metals over here.
No.
That.
There. Go back.
This.
Go back. There we go. Okay. My atoms. The atoms that I chose was neodymium, aluminum, silver, and even one that you may know, which I will explain to you later. So, here we go. Can you guess why they're all similar? Well, I'll tell you. Next slide. The one that I was going to tell you about is silicon. So, silicon, a semiconductor. It's everywhere. It's in our computers, and it's such a common thing, and you might even know it from one of the most known places on Earth, which is Silicon Valley. I'll explain to you why it got that name too. Silicon is quite a mystery. Next, we have neodymium. It's a very useful alloy used in a lot of electronics, and it's known a lot for its magnetic properties, and it's an alloy of two materials that you might not have heard of. Next, we have aluminum. Aluminum is sometimes used over gold in electronics since it's lighter and it's also cheaper. And it's also used for aircrafts like a fuselage or the wings. And a more relatable thing would be aluminum foil. You might have thought of aluminum foil when I first told you about it. Now, silver. If you didn't know already, silver is used in mirrors and it's one of the most reflective materials on Earth. And it's also used for jewelry, and it's also antibacterial and used in gloves. Next slide. So, here's a quote by Bill Bryson. Protons give an atom its identity and electrons its personality. What he means by that is, depending on the amount of protons something has, it gives an atom what it is. Like, if it only has one proton, it's hydrogen. And electrons is personality, like flavor or isotopes. And you can think of it like deuterium, tritium, and all these isotopes of hydrogen. They have the same amount of protons. They're still hydrogen. It's just they're different isotope, different personality, different amount of electrons. Next slide. Let's talk about silicon. Well, all the different forms of silicon or silica are just different forms of network solids and just arranged in different ways, rotations, positions, and tessellations. Because even the type of silicon that you find in the computers that you're running on right now to watch this webinar, even they could be made of silicon, and they're just the silicon in your computers is just a different arrangement of silica atoms compared to quartz and sand that you find on beaches and shores and underneath the sea. So it's very interesting, and silicon has many mysteries. Silicon itself revolutionized the world, and with transistors, which are everywhere. The transistors in all our computers and electronic devices, and even the simplest of electronic devices still have transistors. Well, what are transistors? Well, transistors use silicon and they display on or off, 1 or 0, depending on lower power, that's 0, higher power, that's 1, and this became the basis of binary and all those cool stuff that runs the machinery behind all your computers. And one fact you should probably remember was that it was produced in 1854. Since it revolutionized the world and how a lot of people from the Silicon Valley and companies from Silicon Valley have revolutionized the world, Silicon Valley gets its name as it's a place where a lot of people revolutionize the world. Next slide. Neodymium. When I first say neodymium, I'm thinking you'd be thinking of neodymium magnets, but neodymium magnets are not just for fun or aesthetics or those kind of play neodymium magnets that you can find online. No. It goes much further. It's an alloy of boron and iron, and yet it's still an element. It's known for magnets, of course, and that's exactly its use. Magnets are everywhere, and they're even in the speakers that we're using right now, maybe even in the microphones we're using right now. They're also in different parts of your computer, like your hard drive. Your hard drive probably does have a magnet. Then, if you have a disk reader, that also uses a magnet to read. And you probably have a TV or some sort of internet connection. Of course you do, because you're watching this right now. And that requires some sort of magnet in a transformer that uses electricity to create a magnetic field that creates a bunch of frequencies. That can include radio, that can include Wi-Fi, it can include Bluetooth. It has a variety of things. Next slide. Aluminum. Aluminum is a material. It's quite conductive and it's also quite light. It's convenient for airplanes since it's very light, and it's also used for transmission lines, as sometimes copper for transmission lines can be expensive and or heavy. Sometimes even in our devices, you'll sometimes even find it there. And when I first say aluminum, you're probably not thinking planes, batteries, computers, and all that random stuff. You're probably thinking of aluminum foil that you find in the kitchen. Next slide. So, silver. Silver is used for jewelry as it's very shiny and it's very reflective, as I told you, and it's just for looks. That kind of silver is 92.5% silver and the rest copper or some other metal, and that's just for jewelry. And since it's the most reflective material, it's also used in mirrors, if you already didn't know. And manufacturers and all kinds of people use a complicated process to put glass and silver put together to create a mirror. And it's also antibacterial, like I said. And so some clothes have silver nanoparticles to stop odor that might come off. And strips of silver are also put inside of gloves, so you can use your touchscreens without taking off your gloves. So that was it.
Guess that's it for all our presentations, and now we'll be moving on to the Q&A.
Wait, could we do a bucket?
Huh?
Could we do a bucket? A quick
bucket?
Yeah, a quick bucket.
Sure. Just
Okay.
I'll get a bucket running.
I have been preparing this, and few people already know about it.
Yes, we know about bucket. You'll be the sheriff. Bucket join. Although, did you put the volume on?
94132.
Yes, we can hear it. It's a little too loud though.
You might want to lower the volume.
Why? Just one.
I'm trying.
94132. Yeah. Do it.
You'd want to have to pay attention to all your friends' presentations, or else you wouldn't know the stuff.
941.
232.
Wait. 941 232.
Let's say hackers. 941.
Yeah.
Looks like we have a couple of friends.
Yeah, my friend is joining.
No!
Okay, we have Voltron. Let's
Okay. Oh. Everybody in? Here we go.
flunk this.
Shut up.
Yeah.
Guys, you might want to pencil type. Let's see.
Oh yeah, easiness.
I'm one guy.
Excellent. Bro,
Father,
Yeah, I'm not doing this.
first place, let's go.
I just put pencil guy.
I'm not doing this. I'm good
That's
now.
Alexander Fleming.
First,
I just want to go over to the slide deck real quick. Okay,
You don't have to time.
Is green correct?
Hey, Vivon, you might want to lower the volume.
I am trying.
Click on the volume button up there.
Incorrect. One
Click on the
percent
volume
correct.
button up there.
No,
Okay.
wait.
Oh, hey, who's a hacker?
A hacker.
Who's a hacker? Hey,
You're
I'm
ridiculous.
activating cheat codes. Let's see. What's a negative charge? Oh, we already know this.
This is so easy.
I mean, none of us covered this, but you guys probably saw in the slide. I
Bruh.
guess this is a Q&A bucket. Q&A questions, and except for the ones giving the answers to AI,
I guess.
I
How
guess.
did someone choose proton? Who chose proton?
They probably got positive and negative confused.
I saw
Boron,
red screen on
however,
way
is
down.
Boron
Did you do that
element.
wrong?
Honestly, why did no one name themselves a boron here?
Boron is an element.
A hacker is a raccoon. A raccoon sneaks into the garbage. I'm guessing he shines a raccoon.
What is an isotope?
Less or more neutron.
Why'd you say the answer?
That's
Why
not
did
the
you
answer.
like this fish?
I did not know that was the answer.
That's not the answer.
And why'd you say it was? 3, 2, 1. And incorrect. Come on.
I chose green.
It's
That's
elect-
not fair. I
Oh.
chose green.
Wait, is that correct?
I don't think so. I'm pretty sure it's neutrons or electrons. Or
We
No,
protons.
have the same
it's
number
ele-
of protons but different number of neutrons. We all got that correct.
Yeah, you're the one who put it wrong. Boo at the teacher. Whoa.
I'm not the teacher.
You got it wrong.
It's
But
the one I
It's
said
fine,
I'm
it's
not
fine.
gonna-
Come on.
It's obviously
I-
all of the above. It's obvious.
It's the one I I did not realize there's all of the above. I just put fortified materials.
Fortified breakfast cereal. These are all sources of zinc.
No joke.
Bro. First place, let's go.
Well, we all love fortified breakfast cereals to build a castle out of.
Yee, let's go.
I'm second place.
I'm fourth place.
Yay.
Sad.
Coding. Which ones are toxic? I'm gonna
Because
go
it's easy.
all of the above.
Yeah,
Yeah, it's definitely
not-
all of the above.
It's not.
are you sure?
In fact,
Definitely.
No.
Not saying that
it's not.
sarcastically.
I'm just gonna say. I guess I'm wrong.
There's a
Yeah.
Yeah, I
Ooh.
chose
there's a
lead.
big
None
problem
of us
with like
ever said
lead.
lead
They
yet.
said
Lisa
like
said
there's
that
like
titanium and platinum are
was, like,
non-toxic.
they
Yeah.
I heard like an issue where like poisoning because like people
How
didn't
is
have like lead.
lead is toxic?
Yeah, lead poisoning is like
Losing the
popular
clicker. What is this?
One.
One of the oldest
platinum
platinum found. Let's see where platinum is. Come on, where's
I
platinum?
know this.
I wonder. 17th century mine in India. 8th century casket from Egypt. 20th century luxury company.
I'm guessing it's from 18th century. South
Wow,
America.
I answered this wrong. That's kind of sad.
How?
And right,
You talked about it.
it's your.
I know, which is why I said it's kind of
Well,
sad.
it did say loading the missed clicker.
Let's go.
Loading the misclicker.
I have a
You're last.
Who is Voltron?
me. Last question.
Who
Oh,
created the
the
periodic
periodic
table? Come on.
It's,
Oh,
it's
this is so
Nelson
easy.
Mandela.
totally Gregor Mendel. It's totally Gregor Mendel. I mean, we all know that it's Gregor Mendel. There's no way it's not Gregor Mendel.
John.
It's not.
Actually, oh, I misclicked.
It's not to know.
Mandela.
You'll see.
Right on this one.
I misclicked.
See, it's Gregor Mendel.
I got it right.
Dimitri
It's basically the same last name.
Mendel, really?
Oh my
Good
god.
job,
Who's
Vivon.
Voltron
Who's
over
Voltron?
Me.
Vivon. Good job, Vish, and good job, Beta. Thank you, Ishan, for playing. So that was our terrible Q&A bucket.
Well, who wants
I
to
answered my own
do
question
a
wrong,
different
that's
game
nice.
mode with the bucket?
Okay, so, which element do you think is the most common out of the ones we discussed?
I chose titanium.
Hydrogen.
Yes,
Oh,
hydrogen.
Hydrogen or hydrogen?
My mistake.
Of course,
What do
it's
you mean,
hydrogen.
which you think? It is which is the most common.
Yes.
Aluminum is also like really.
Yes, but hydrogen makes up 75%
Okay,
of all matter
except-
in the universe.
Except hydrogen.
Aluminum.
Aluminum, I think.
Are you sure?
So, Vivon, what did you cover for this week's topic? What element?
Hydrogen, uranium, and thorium.
Looks like
Explosive.
Lemuel disappeared.
Ah, yes.
And what did you cover? Chemical 3?
I think.
Chemical 2 disappeared.
What did chemical 3 cover? This
Why
week?
am I Hydrothor?
No, the other people are
What did you cover? Chemical 3?
If hydrogen is combustible, then am I sleeping on a fire hazard? No, you are not actually, because the air around you is not going to light on fire anytime soon, Ishan.
Man.
But good question.
Yeah, of course. We all want to know if we're gonna burn ourselves. I mean, we're practically all.
Ah, yes. I just bring up a lighter. The air around me sets on fire. Wow.
But hydrogen is not that combustible, and we don't have such a high percentage of it. And
Nice aluminum.
wait, that looks like your friend's there. Does she have any questions?
Yeah. Do you have any questions?
No. Data.
Do you not have any questions?
And now I will put my.
Vish, do you have any questions?
Oh, yes, I have a question.
Is
Periodic table.
oh, I have a question. Is fortified breakfast cereal real?
Yes. It's cereal with nutrients in it. Basically, like,
Yeah.
they put pills in the breakfast, except there are no pills.
Let's just fuse the cereal with a bit of titanium to make it
Ah,
fortified.
Uranium is perfect. It'll go in the mix.
Yeah. Let's add in
Let's put
some
some
platinum
hydrogen in.
cherries.
That will work.
Why don't we add in some platinum cherries?
Ah, yes, platinum cherries. Perfect.
And then we'll put
Yes.
in some silicon flakes.
What? Tiny.
Silicon.
Uranium cereal, welcome to the future. Uh-huh. Here we go. Oh, oops.
Which one of you knew that silicon was a semiconductor and it's on our computers?
Me.
I did.
Me
What?
only because of you.
Looks like Vish doesn't know.
Wait, what did you just?
I did because.
Hey guys, here's the cereal of the future.
My Google
Uranium
Drive.
cereal.
What? Okay, let's get back on.
Radioactives.
Okay.
Interesting.
Vish, stop.
Yeah, I got it.
Okay, do we have any more questions? I'm being serious.
No.
Ah, yes. Periodic table. Question mark.
Ashley.
Okay, so that was all for this webinar.
Bye. After one more final message that I have to.
What? Huh?
Okay.
Oh, yes.
That was all for this webinar, everyone.
Yep. Now let's
Bye.
start the recording. What should we?
Wait, you're platinum.
Yeah, I know.
The
Titanium.
I
Okay, how do we
think
stop
all,
live stream?
all the way, Zinc all the way.
How do we stop live stream?